Hello everyone, this is Dr. Tina Mims, and I want you to take and follow me along on this video on how to estimate the sample size that you need for a population of interest using the confidence level and the z-score that's associated with the confidence level. I have copied here from the textbook the standard sample size formula. And also from a previous slide in class, I've brought over table information so we can see the confidence intervals here used and their associated z-scores. So let me take a moment just to remind you what we know about confidence intervals. Let's say we have a confidence level or interval of 95%. That means that 95% of the time, we are going to be able to estimate the true mean average of a population. For a 95% confidence level, there is an associated z-score right here, because this z-score explains above the mean, we're going to know 47.5%, and below the mean, 47.5% is going to be explained. Do you remember the bell curve? Because we discussed the central limit theorem. Well, imagine that bell curve with a line in the middle, and these z-scores correspond to a percentage above and a percentage below that we are explaining, and the 95% says what our level of confidence is that we're going to be able to guesstimate the true average of the data we collect, which means 5% of the time we're not. So now you can see if we drop down to a 90% confidence level, well, we have a 10% chance of not estimating the true average, true mean of the population with our sample. So that's why it's important that we have the background information on this. Okay, pause this video if you will, and go ahead and put in these data points. When you're setting your spreadsheet up, be sure that you're putting in the correct column and row where I have my Z, P, Q, and E. And as we continue with the video, I want you to follow along and be sure and place the equations in the same cells that I do. I'll give you a moment to do that. Okay, you likely paused your video and have set up your spreadsheet the way I have. Go ahead and type in 1.96 because it's the most commonly used confidence level, z-score. You see there? So we're actually saying we're interested in a confidence of 95%. That means that we then have to use the z-score in our calculation. So we're going to put that information in. And if you go to the textbook and look at the Domino's Pizza data that they gathered, they found out the answer to a question was, what is the likelihood that your next pizza will be Domino's? And the answer of yes turned out to be 50% of the people's responses, okay? So we're going to put in a 0.5 here, but we have to calculate Q, because Q is the remainder of 1 less whatever that P estimate was, okay? For now, we have half answered yes, so the remainder that answered no is likely the remainder, which is 50%. Also, in this piece of information, we need to also be given or determine in our meetings what is the acceptable margin of error. So now what is an acceptable margin of error, and what's that mean? Well, similar to what the textbook says, but maybe giving you a real-life example, is often when you see the news reports saying that 45% of the people agree, or 12%, even worse, 12% of the people agree that our food sources have been contaminated. But the margin of error could be plus or minus 10%. Well, if 12% of the people believe that, then that means the range is between 2% of the people, actually all the way up to 22% of the people. So when you have a wide margin of error, you have said that your confidence is less on the information that you've gathered. So for the Domino's Pizza example, they listed that it would be okay if they had an acceptable margin of error of 0.05%. Remember, that is 5%. Let's just put these in as percentages there. So we have a 5% acceptable margin of error, and now we're going to calculate the sample size using these pieces of information. Okay, the first thing we're going to do and take care of is in the numerator, we need to take and calculate the squared number for z. So I'm going to put in here, and I'm going to use, notice, one single not hypothesis, but quotation, so that Excel won't read this as a number. And I'm just simply going to write out what we're about to calculate. The shift key at 6 has a little hat on it, and I'll explain to you what that means, but basically it's a square root function. So let's go over here and now actually calculate the squared function of 1.96. So we'll do that together. Now we'll put in an equal sign. We'll hit this cell where we have our z-score information. Then we're going to hit Shift 6 so that we can put that little hat symbol in there. And since we just want it squared, we'll put in a 2 and hit Enter. So now Excel has calculated for us this little piece of information, z-squared, using the information we said we're using for z. See, if we were using a different confidence level, we would change that z-score. Okay, moving on, we need to now get P times Q. Again, I'm going to put a single quotation so Excel won't think it needs to calculate anything, so I can write stuff out. So now we're going to actually calculate P times Q. So this is just me writing text about what we're doing, and now we're actually going to calculate it. We'll hit equal, and then P, Shift 8, get the little asterisk, times Q, and hit Enter. So now Excel has calculated P times Q for us. All right, now let's make the product of all of this numerator right here, which is z-squared times the product of P times Q. All right, so now I'm going to remind us what we're doing here. We're doing z-squared 2 n times P times Q, so that we'll know that when we actually hit the equal sign here, take our value for z-squared and multiply that times the product we received for P times Q. We know we have our numerator now for this formula. Isn't that great? Love that. I love breaking down a formula like this. Okay, now we need our denominator, which is the error squared. So once again, I'm going to type in an explanation of what we're going to calculate. All of my information in C is the calculation. So here we'll simply use the same method we did earlier with Z. We'll use an equal sign. We'll go up and get our error. We'll hit Shift 6 so that we get the little hat that tells Excel, hey, I need to square this, or cube it, or quad it, or whatever number we put in there. This time we just need a square, so we need E squared here, and we have these two numbers now. We have our numerator and our denominator. So now we can actually estimate the sample size, N, which is equal to our numerator divided by our denominator. So it looks like we need a sample size of 385 people. I would actually do a round up. And to do a round up, you simply type in this information May need a little extra bit of. So to make roundup work for us, because see that number hasn't changed, notice I have roundup, I have a parentheses open, and then another parentheses open so we can have our numerator divided by our denominator first, then a comma, and this tells it needs 2 decimals, but if I really want it to round up to a whole number, I need 0 decimals, correct? Let's see what happens. Hit enter. Sure enough, Excel has rounded up our sample size estimate to 385 because we can't interview a portion of a person. All right? Now, just real quickly, to test that our formulas are working, we're going to go in and give the other piece of information from Domino's. Second time they ran their study, 90% of the people said yes, so we'll put in 0.9 here. And look at what happens. As more of the individuals sort of tend to agree, then our sample size drops down, and that's because the mean for this group has less variability. Now think about that. Instead of half and half saying yes and no, we have 90% saying yes. So I hope this video has been helpful and that you can use it to calculate sample sizes in your homework and on your projects.